Alright, so welcome to the basic course on AWS. So we are going to cover the basics of AWS in this course, and this will give you a head start, a kickstart in your AWS career. So let us see the contents of this course. First of all, we are going to see how the internet works, because it is important for us to understand the client server architecture, just the overview of it, so that we can get to know what are the cloud computing benefits and what are the differences between traditional IT infrastructure and cloud computing infrastructure. Next, we will see the traditional IT infrastructure, then we will see cloud computing, what it is and what are the needs that users that weren't fulfilled by traditional IT infrastructure, or what were the drawbacks of traditional IT infrastructure that users have to shift for cloud computing. Next, we will see the types of cloud computing. Then we will see IAM. It is the service to manage the users, groups, policies and roles, and also we create multiple users for a single AWS account and assign them permissions, so that we can tell them what kind of operations they can perform on the AWS account. Okay, so this is for security and for control. Next, we will see what is EC2. EC2 is the compute service of Amazon. We will see its types and we will see the security groups as well. Next, we are gonna see the EBS. EBS means Elastic Block Store, and it is a block store service for AWS. Next, then we will see AMI, EC2 Instance Store, and EFS. We will see the differences between them. AMI is just the machine. Full form is Amazon Machine Images, and it is used to tell what kind of softwares and what kind of operating system will be installed on our EC2 when we launch an EC2 instance. Then we will see what is availability, what is scalability, and what is elasticity. Okay, these are the hot terms of AWS or any cloud computing service provider, and then we will know the difference between these are interrelated but are different. Then because of these three things, we are able to achieve these two things, which is ELB and ASG. ELB stands for Elastic Load Balancing and ASG stands for Auto Scaling Groups. So we will see this. Next, we will see S3. What is S3? Then we will see policy and static website in S3. S3 is a storage service as well. It is an object store service. Next, we will see the databases, and in the databases we have many databases like RDS, DynamoDB, and a lot of them DocumentDB. Okay, but we will only see the RDS in detail, because this is the service which most of the users are going to use who are in this course. Then we will see the basics of VPC. VPC is the networking service of AWS. So now let's see how the internet works. So suppose this is a client machine, and client is connected to internet, and any server machine is also connected to internet. So this is a server machine. Okay, so just say that this is server of wikipedia.com. So if I want some results, I want to search for something from Wikipedia, so what I do with the help of internet, I request wikipedia.com. I request wikipedia.com for a web page. So what I have done, I have put a request, and in return the server will serve my request, and what will it give to me? It will give me a response. So this is what the client server architecture is. The client requests to the server and server serves that request. Okay, this is also known as request response architecture. All right. Next, we will see that servers are computers with powerful hardware configuration. Okay, so the server is a heavy machine, and why it is heavy, why is that there is need to make it a powerful hardware machine? It is because a server has to serve the load of multiple clients, as we can see in this image, that only if you are accessing Wikipedia, then it does not mean that nobody else is accessing Wikipedia at that time. Thousands or millions of users might be accessing Wikipedia at the same time at which you are accessing. So the server needs to be powerful, so that the server can take the load of all the clients and serve their request, and it does not fail. So how does it make powerful? We make it powerful by adding the expensive hardware which have more processing capabilities. Next we are gonna see a server has CPU, a server has CPU, just like our normal PCs have. A server has a CPU, and a server has RAM, server has storage, server has database, and server has a network. A CPU which server has is a heavy CPU like Intel Xeon and so on. It does not have CPUs like i3, i5 and i7 because these are supposed to be for personal computers, because they cannot take up a load of multiple users. They have RAM from GBs to TBs. They can range from GBs to TBs depending upon the server configuration and the type of load the server has to take. They have vast storage, they have database service as well, and they have high network processing capabilities. Okay, they have high network processing capabilities. Why is there need of high network processing capabilities? Because multiple clients are putting the request and it has to serve the request of all of them at the same time simultaneously and send the web pages back which they have requested. So the need of heavy network, high network speeds and high network interface card is needed. So now let's see what is the traditional IT infrastructure. So for example, a business is small, so in the beginning they may start from their home, and when they grow, when the business grows, when the number of users of their products or services grows, they can start a small office. But if they become very tech giant or giant of some industry, then they need to have a data center like giant companies like Facebook and Amazon have. Okay, so there is a lot of cost associated with maintaining a data center, which is a downside of traditional IT infrastructure, and because of which people are moving towards the cloud computing architecture or infrastructure. So let's see what are the downsides of the traditional IT infrastructure. Number one, cost of space for data center. So data centers are big because they have multiple servers. So you have to pay for the cost of the space, the cost of the land where the data center is being kept. Okay, next is electricity bill, cooling concerns of the server. So you have to pay the electricity bills yourself, and you have to set up the cooling of the servers. Okay, you have to do it yourself, and all of these things bring a lot of electricity bill with themselves. Next thing is overhead of replacing the hardware, example upgrading the memory. So for example, you wish to upgrade the memory in the traditional IT infrastructure, then you will place an order for the memory, and then after weeks it will arrive, and then you will give it to your managers or IT guys, and those people will put in the memory. So this is how you will do a replacing of hardware in your memory. But take an example that this is upgrading, so you have planned to upgrade it, but what if the memory becomes faulty at any moment of time? Then your business may go down. Okay, so next thing is salaries of data center employees, example managers and security guards. You have to keep these peoples and you have to pay their salaries. Next thing is, what are we going to do in case of disaster and earthquake? So if our data center gets damaged or destroyed, then our data is gone. Okay, so we have to keep multiple data centers at different location, which will put a lot of cost on us. Okay, so these are the downside of the traditional IT infrastructure. Next thing we are going to see is what is cloud computing. So cloud computing is on demand delivery of resources like storage, compute, etc. So we will get resources on demand. For example, now I need a computer with 4 GB of RAM and 2 virtual CPUs, then I can get it within a game of a few minutes. Okay, it is on demand, and I will get those things as a service. I will get them virtually. How? We will be seeing that in practical in the coming sections. Next thing is pay-per-use pricing system. So for example, you have used this machine which has this configuration for 1 hour, so you have to pay only for the amount of time you have used it. So for example, the cost of 1 hour is $0.5, so you have to pay that much amount only. Okay, you don't have to pay extra. But if you are having a traditional IT infrastructure, so no matter for how long you will be using your server, you will be paying all the amount upfront, all upfront for your servers. Okay, so that is the downside of traditional IT and upside or a benefit of cloud computing. Next, get the exact type of server or a resource you require at the moment. So for example, my load is on my website is just like that. My 4 GB RAM computer having 2 virtual CPUs can handle this load, so I will get this computer only for that moment. And if after few months the load gets increased, then I can get a computer with 16 GB having 4 virtual CPUs or anything that I require at that time, and I can discard this server. So I will pay for the amount of time which I have used it. But in case of traditional IT, I would have to keep it or sell it, and I would have to pay the entire price when I was purchasing this item. So in the cloud computing, you get resource which you require, the amount of specification you require at that moment. So you do not need to spend a lot of money, and the resources are just a click away. You can get your resource within 2 to 4 minutes or even less when you are needing a resource. Okay, remove resources when not needed. So for example, after a few time the load gets increased on your website a lot more, then you can get a computer with 32 GB RAM and 16 virtual CPUs. Just for example, I am taking this, and you can discard this server. Okay, so remove the resources when you don't need them. But if you are using a traditional IT, then you would have to pay the entire amount, then you would sell it and all the stuff, the cost associated with it, and the overhead of acquiring these resources, placing the orders to companies to provide you these resources. But with cloud computing, you can get these resources just a click away and remove these resources whenever you don't need them anymore. The next thing is the general cloud computing advantages. So in the previous example, we saw that according to the load we purchased our EC2 instances or the servers, so we do not need to guess the capacity that after 1 month the load will be this much, so I should buy a higher or much higher CPU. So you do not need to guess the capacity, or because you also have auto scaling groups which will add more instance, which we are gonna see in a coming section, that auto scaling group will add more instances depending upon the load on our website. And then agile means fast, so we can get the resources very fast. The cost of running data center is saved. For example, electricity bill is saved. Okay, and the cost of managers and the security guards, all of those things are saved. And next thing is that cloud computing is a global service. For example, I can launch my servers in Tokyo if I want. If my users are in Tokyo, then I can launch my servers in Tokyo. I can launch my servers in Mumbai if my users are in Mumbai, and I can launch it from any place in the world to the any available region which the AWS provides. Okay, so that my users get less latency. Next thing is scalable. We can add or remove resources anytime, and this thing can be automated as well. Next is cost effective, because we have to pay for the amount of time which we have used the server only. Then high availability. So I can launch my server from the comfort of my home or office in Tokyo or in Mumbai, and if my Mumbai server fails, then my traffic will be transferred to Tokyo. Obviously it will have a little bit more latency, but my application will be up and running and I will not face a lot of business losses. So this is what high availability is.